Welcome in this new Rebel tutorial. My name is Gabriel Neville, I'm an FX lead at MPC, and today we're going to learn how to do this disintegration effect. First, we're going to look at how we can art direct our mask destruction with clusters, procedural animations, and particles. Then we're going to go through the different secondaries we can add, like smoke, pops, advected debris, and flames. And then to finish, we'll have a look at creating custom AOVs and tech passes to have more control during the compositing phase. Let's hop in. Okay, sounds good. So I think we can start with the rotation of our pieces. So in order to do that, we're going to create a wrangle here, and we're going to use the active frame attribute that we stored, So if here I'm just going to highlight this one. And basically what we want to do, we're going to create a multiplicator based on this active frame. So if I were to do like an amount, basically a float between 0 and 1, it's going to be like the multiplier on our rotation amount that we want to do. So we're going to fit frame, then active frame, and then we're going to put active frame plus duration, and we're going to fit this between 0 and 1. Obviously here we didn't declare the duration yet, so we're going to create the duration, and we're going to give it a channel integer, and then we're looking for the parameter, and we're just going to give it like 10 frames. And for now, we're just going to visualize it, and we're going to put CD equals amount. See if we have something. Okay. So you can see that now we have this kind of like an age kind of thing. And so basically here, basically the amount of rotation that we're going to do is going to be multiplied by this. Here we can actually put like a way bigger number, maybe 50 or like 100, just so they keep spinning around. Let's put 150. Cool. So it's going to be rotation. All right, amazing. Obviously here for now, nothing happens. We just play with the color. So yeah, I think that's it for now. We're going to use basically more or less the same technique as what we did here. We're going to rename this one, by the way. Okay. And yeah, I'm going to steal this, just the velocity at the end frame, and then I'm going to let's go over the amount. Okay, and now we'll have this angle. Okay, let's delete this. And now if I put like a big angle, let's see if we see something different happening. Okay. Yeah, something's happening. So let's put a smaller angle. Okay, let's just actually have a look at the orient. Okay, I don't know why nothing's happening now. CD and out, it's always good. Anvil. So we have a constant point count, so this should work. And do we have a velocity here? We don't have the velocity? Oh, okay, so that's why. I don't know why. Forgot to copy the velocity here, so I'm just going to compute it again. I'm just going to match it by ID, just in case. Okay, so basically that's why we didn't have this working. So then if I just bypass it, was this the reason? Let's give it a big angle. Okay, so now we give like a really big angle. Seems to be working. So let's do a small flipbook on the last frame of it. See if this additional rotation is working. Okay, so like here we can already see that we have some of the pieces kind of spinning around. Okay. So yeah, I think it's not too bad. Maybe the amount is a bit big now. We can be maybe a bit more subtle than this. But once again, it's going to be covered by some secondaries anyway. Um, so let's give it just half of it, 500, and so we can call it good. Guess at least now we know that we have those velocities. Okay, great. So this is about the rotation. Now we're good. The next part now is going to be about the extrusion. So we're going to give a bit of thickness to this. So to do that, basically, we're just going to do something on the side. We're going to take our in geometry. Okay, and so basically, yeah, just a very simple extrusion here. We're just going to be pretty subtle with the values. So here I'm going to go for 0.0.003. And I'm also going to output back. Verse, and for I'm going to actually transfer the normal. Okay. So first, let's see the amount of thickness that we created. Okay, so obviously here, a bit too much. Maybe I'd, yeah, so I think it's probably going to be 0.00, like we need to add like a last, another 0 here. Just so it doesn't explode everywhere, and might look a bit thin, but like we're going to add some extra thing under it. But it's okay, like, you know, at least if we were to do an exploded view just to actually check the thickness. So yeah, you know, it's okay. I think it's good. So these values are nice. Now we're transferring back the normal. Um, this should be matching. And did we have all the normals actually on the vertices? So we just need to switch here, points to vertices. I think it's something that's a bit crashing. All right. So I think it's going to retransfer all of it anyway. Okay. So this, then we're good. Then we're just going to regenerate. So basically here, what you can see, we're just, I forgot to actually do it. I'm going to create those groups. And I'm just going to put them like a shorter name, so front, back, and side. And yeah, what's going to be face now is going to be the back because we're extruding in the negative. Front's going to be the back, and side is going to be those edges that we just saw. So now a bit painful, but we need to just regenerate that. We're going to regenerate the normal for the side, and we're going to reverse the normal for the front, which is the back. So angle minus n, there's normals, insertion to vertices, and then here I'm going to put a connectivity node, and just switching to primitive, and I'm going to attribute promote the prim ID. I'm going to do primitive to primitive, but with a name attribute called a class, and it's going to be switched to maximum. Let's do a small file cache of this. So let's just remove time dependent, base name, $s, and here we're going to say bake extruded geo, and I can save to this now. See, now it's cooking. And basically, so like few things here. Like the first two things were about regenerating those normals, so creating new ones for the side, and just reversing them for the one in the back. But then the last thing that we did here with the connectivity in the prim ID. So basically, by default, the poly extrude won't keep the prime-ID attribute. This is like true about kind of everything. So you kind of need to ask him to re-copy that. We could have done a for each, but here in this case, I know that basically they're going to put all the prime-ID by default to 0 on the side. Is it prime-ID? Oh, it's actually, yeah. I'm actually just going to put it to point from point primitive here, and I can just resave it. And we can do actually like a small, very small example. Let's select one of the pieces, so I can do type 9 in the viewport, and click on the wheel, and I'm just going to select by class. So let's just select one of the triangle, switch to delete non-selected. Okay. And now we're going to do a color. And it's going to be random based on prim ID. Sorry about that. Let's just remove the material. So we can see that they actually have all of the same prim ID. Okay, maybe now with the latest pull extrude, this has been fixed. So you might not need this, but I mean, in some version of Houdini, there was like not copying the attribute. Oh, I think we had it. No, they all have the same prim ID. Okay, so it's great. This is just something to do. Basically, you can just promote to maximum. That way, if you see some attributes that are not copied, it's going to be 0, and they're just going to be copied correctly. Okay, so this is good. At least we have this now. This is prim ID. And so in my case, then I will just put it back to point. First match, and that's it. Cool. So few things. After I'll show you how to create custom AOVs. There's one AOV that can be interesting to do, is to isolate those front, side, and back. So I mean, we can already set it up already. So I'm just going to create a wrangle, and we can call this. Actually, we're going to put everything in a vector. So I'm going to do something called group. I'm going to set this to 0, 1, 0. Going to be green, and this is going to be forward or back. Then same, we're going to do side. We're going to do. Let's put them red. And the last one, we're going to put a blue. For the prompts. So just basically here, this is just a small AOV thing that can be helpful if you want like to put a bit of glue on the inside surface and all this, or make them a bit darker in comp. That will come handy. All right, and then here, the only thing that we're going to do, we're going to attribute copy from here to this guy. I mean, we could directly take it from here, I guess, to avoid having a double attribute copy. And actually, we can just copy the same one. So here everything should work. So if I were to put a switch, and actually now switch from our thin surface geometry to the poly extrude one, everything should be reattached properly. Is it the case? Yeah, okay. Cool. So yeah, now everything has thickness. So it's going to render it way better. We're going to have like, all the small highlight on the edges and all this, and it's going to feel way more 3D than just thin surfaces. So yeah, I think we're pretty good now for the main disintegration effect. So basically, I can just put an out here, put it red, and I'm just going to organize a bit our scene. So here I'm just going to put a small sticky note extrusion geo, and here I'm going to say pop activate. Say okay, and so yeah, that's our setup, and here like our output. Great. So now in the next part, we're going to we can start with the smoke. So I'm going to show you guys how we can create some smoke sim out of this to fill up the gaps. Then we'll go over the particles. We can create a bit more thickness to those pieces as well with like another separate layer. And yeah, then we'll be kind of good. So yeah, let's do that. Okay, so in this case, we're going to create a new geometry here. We're just going to split one geometry per layer. So this one is going to be the smoke. And right off the back, we can put an object merge. And here I'm going to put a null after an attribute copy. And we're just going to call it in geo HQ. Take this. And yeah, so we have this one, and now we're going to put same a null here, and we're going to call this in PC for point cloud. And so here this one's going to be get geo get point cloud. Okay. And we can actually copy these transform pieces here. So here I'm going to do a blast, and I'm just going to keep the inside to the inside or the other side. Okay. So we know we have those ones. And we're going to put a scatter node. Obviously, we can remove relaxed iteration, and we're going to put quite a lot more of points, so we can increase the max limit and the force total count. So now we have 1 million points. Not bad. Let's maybe increase it to 5 million points. Okay, so this seemed pretty dense to me. And in output attribute, we're going to output the piece count. It will come handy after. Cool, so now if we do transform pieces, you can see that the oldest cluster name attribute got like generated to the point, so now we do have the points moving the same way our disintegration thing is moving. It's pretty great. I am going to put here an ID, so I'm just going to do ID equal pt num, and I'm going to find the near points, so we can actually here just copy this triangle. Instead of cluster name, in this case, we're going to put cluster name 2. Because we want even to source smoke from the smaller gaps. So if we switch to this, it can be a bit long to compute, but yeah, then see what we have. Perfect. So mostly red. Cool. And now we're transforming this. Once again, we can copy the same activate thing. So copy properly. And for in this case, I don't remember exactly. I put 1.5 so we can make this one a bit more sensitive. Sensible. Okay, and you can see that we have our stuff that activate properly. So now we have like a pretty dense point cloud, and it's going to be where we source the smoke from. So now I'm just going to do a blast. We already have our active attribute, so I'm just going to put here blast and do active equal 1. Switch to point and delete non-selected. Great. Now that we have this, basically, one of the first mistake that we see in Pyro is those substep issues, where we're source a particle here, then the next frame is going to be here, and then we start to have gaps. So the best way to fix that is just going to trail. So basically, here, we're duplicating the point. We're putting the point at the frame before. Here in this case, I also increased the trail length to 3. And remember here we had this ID attribute, so I can actually create a line from this. And it's going to be by attribute ID. So now we have those lines here. The only reason why we can create lines is actually if you want to resample them. So that means if we want a denser point cloud. So some basically because the volume rasterize. So the way we're sourcing smoke is just going to get the point itself at the moment. So that's why if we actually throw a sample here and we reduce this quite a lot subtly. Okay, now we can see that we're giving more points to the rasterize, and we can actually go thinner a bit than particle scales, and you will have something that looks a bit sharper. So yeah, that's about it. Then we can, once we're happy, we can always just remove the lines, but keep the point. So just this operation went from 400k to 1.1 million. And now let's just actually create our density attribute. and this density is going to be 1 minus curve view. Curve view is an attribute that we didn't create just yet. We can create it. You can click on the resample, and curve view it is. So if I were to do a color here on the side and visualize the density, I can switch this to ramp from attribute and then here density. You can see this is what I get. So basically here the idea is like we'll source more smoke on the direction of the vector, and less, like we have this kind of gradient from one part of the line to the other. So this one is called density, and then after that we're going to multiply this time a multiplier, and here we can actually put the temperature equals this times like a different threshold. So let's put the temperature here, multiplier, and this one density multiplier. So I think here in this example, temperature multiplier is 10 as 1 and density multiplier is 10. Here it's just like 2 have like an easy control if we want to source a bit more temperature. And now we can always, we're going to start rasterize it. So basically I'm sure you all know how smoke works, but basically we go from, points that have coordinate in 3D space to actually voxels, so like small squares, kind of like pixels, but in 3D. And so each of those voxels are going to have a value. It can be a vector, it can also mean a float, and here in this case, it's going to be a float. So I'm going to reduce the voxel size to something quite small, and I'm just going to rasterize this density, temperature, and we're going to store the V as well. So here, if I increase the P scale, all right, cool. Now I can see my stuff. So basically, that's why I usually put P scale, because like it's giving me something a bit more, like this P scale attribute is going to be multiplied by this P scale. So sometimes like when you forgot to put a P scale and it's basically going to be by default 1, it can kind of explode your thing depending on the scene. So that's why I prefer to just have like this multiplier, just to see if I want something a bit thinner or bigger, but at least I know that I'm working with something relatively in the good scale in terms of particle scale. Yeah, and now we can do maybe a small velocity blur, see if that does something. And in here, let's try to reduce the voxel size to get something a bit sharper. Okay, and here we can do primitive. And just to visualize this, I prefer to always put invisible for name V. That way we know that it's not V that we're seeing, this is like density. We can actually put this for the temperature as well. Here in this case, we will not see it, but sometimes you can see velocity that have like big values, so they kind of like are overwhelming, and so this gives you something to do in general, just so they don't show up in the actual viewport. Cool. So this is our source. Perfect. And we're going to create now a dot network. And we're going to do a Pyro solver sparse. And we're going to volume raster, volume source, putting into sourcing, and we're going to put a smoke object, sparse as well. Cool. And yeah, now I'm just going to do some drag and drop stuff. So here I'm going to copy the voxel size into the voxel size of the Pyro. So that way if we change the voxel size here, we'll automatically put the thing at the right spot. And for this one, we're going to give it a bound. So here I'm going to put a time shift, delete channel. And I'm going to call this inbound. And here on the wheel, I'm going to add a spare input, drag and drop it. And basically, I'm going to put this in the centroid of this bound. So like basically, like, you know, sometimes you can be a bit far from the, by default, it will try to create put the simulation here at the very center. The thing is here we're already kind of a bit far away from it, so the best is to specify the center of when we want to be. So to do that, we're going to create this, we're going to put the centroid expression. We're going to put -1 because we're targeting our spare input. And we're going to do dx for the x-axis, the y for the y-axis, and the z. If I click on this, you can see that we have now some values and that the initial bounding box is going to be at a place where we want the simulation to happen. So yeah, that's pretty handy. For our volume source, so we're going to drag and drop this, and we're going to redo this so it's more initialized. That way we have density, temperature, and velocity directly added, and everything rests, looks pretty good. And so yeah, like here the best, like the way I like to visualize this is directly to create my DOP import field, switch to smoke. Usually I don't take the rest. We're not going to need a temperature, just density and veil. I'm going to drag and drop the DOP network here, and the DOP node is going to be the smoke object here. Cool, let's see now if we press play, if we can see. Kind of something. So we have something that looks a bit slow here. What we can do here in this case, we can just reduce a bit the amount of point that we're giving. Just to test it, and then we'll have something that. Okay, yeah, it looks a bit more reactive. Okay, and it just maybe like we can start directly into a frame where there's already a lot of smoke that's supposed to be sourced, and see if something happened. Most likely it won't, because basically what we need to do here, we need to do a large field to contain the source. So that means that we're forcing Pyro to at least take the minimum size of the source. Cool. So if I just put 62, let's just try to see if something is working out of it. All right, so like now we can already see, let's see how our CPU is computing. Here you can see that it's already a bit long for the first test. So let's try to reduce some voxel size. Hopefully it doesn't crash. Let's see. Okay, I'll go and crash. Let's just save it, increment it. Okay. So here it looks like, oh, rasterize is already a bit long to compute. So let's do. And so now there's something about padding. So here you can see that we're working in a pretty small scale. So by default, there's something called padding. I'm just going to reduce this. And basically is how much padding do we want to like around this bounding box. So that way, like, you know, if we're pushing something in the direction of the velocity, it doesn't like just collide with the box, right? So here you can see that we're at 0.002, but by default, the padding are actually pretty high. So you need to click on Pyro Solver and you go to Advanced, and we're at 0.3. So that's actually very big in our case. So let's just reduce that and see if we have a better luck now getting some data playing more or less in real time. That's what we're hoping for. Okay, so it's not real time, but at least now you can see that almost real time. Like we're like, you know, we have more time computing the source that actually doing the solver work, you know. So it's something. Here, first thing you can see is like we see those very high velocity pushes. Those are actually coming from our temperature and our velocity. So first, I think we can actually remove any buoyancy, and we can just reduce quite a lot the amount of velocity we want. So 0.1, for example. And now we can actually just see that works a bit better. So obviously buoyancy is like the force, so based on temperature, it's going to make the smoke wants to go up. So here with the scale, we will have some extreme temperature, and like the scale of the buoyancy is way too high, so everything will want to go up. All right. So now we kind of see already the smoke is kind of evolving. We see some velocity pushes. Okay. So it's pretty good for our first test. And just to talk about the padding again, we can actually see those are the padding. So for now, we seem to be pretty confident. Here I press on W, by the way, just to see the wireframe. Otherwise, you can do it smooth wire shaded. Wireframe? No. I don't know why we don't see the banding box. But yeah, basically now in terms of padding, we're way better. So something to just basically do depending on the scale of your scene. Okay. So now, oh, I had it, yeah. You can see the bounding box of it. Cool. The thing I like to do in general now is going to be noise or velocity. To noise or velocity, you have like different options. One that I like is actually storing the speed. So I'm going to store speed, and I'm going to create like a speed attribute, and it's going to be the length of our velocity vector, because speed is the length of velocity. Just doing this, and then I'm going to normalize our velocity vector, make them of a length of 1. We're going to do an attribute noise, and I'm going to noise v. Here. And if I try to display, let's just switch back to yeah, lower until samples, just to make it a bit more easy to navigate. And here in the guide scale vector, I'm going to reduce this quite a lot. Okay. All right, cool. So obviously here we're going to switch to 0 centered. That way we can also add some negative values. I'm going to reduce quite a lot the element size. The element size is basically the frequency of the noise. So putting something a bit small as well. Let's just actually put slightly more. Okay. So here you can see that we go from here to this. It's not too bad. And we're going to reduce this quite a lot. 0.5, let's say. So we added some stuff. So you could argue that basically the length of the vector has changed. So we're going to renormalize it. See, now we have like this normalized thing. And now if we just basically multiply it by the speed that we already stored, so v times equal speed, we're going to have the same length that we had before. So that if I just go back to scale vector point to 1 and say, now we have the same length as before, but now we have something a bit more broken up. And yeah, then here we can just break it up as we please. This frequency looks nice. Yeah, just 0.5 I think is going to be good. And here in this case, I can just make voxel size a bit thinner just to get something a bit sharper. Okay, I think it's looking pretty nice, our sourcing. So let's go back to our dub import field. And let's just do a small flipbook. Okay. So we got the data. Okay, so now we have something, yeah, way more high res. And you can actually see now the motion and the smoke pushing into the different directions. All right, cool. So this is like for the proof of concept. So we have our smoke is kind of working. So now we can just put back to the first frame. actually, just before we do that, let's just dive a bit into the microsolver. I'm going to call this source smoke, and the other, gonna like this. So microsolvers are how the volumes are behaving into this world, this container. Here you can see by default is we have dissipation at 0.1, which basically means that we're going to remove 10% of the density per time unit. So you can see here a value of 0.1 is that 10% of the smoke will disappear every 24th of a second. Or like, you know, like, so basically like this is based on the time increment. Here we have like by default time increment of 1 out of like 24 frames per second. So this is how much smoke we will lose every frame. So this is the type of microsolver. We can do disturbance, shredding. What I like to do in general is use a node for that. That way I can add like different level of gas disturbance and turbulence and all this. So here I can put a first disturb, and I'm going to call this disturb low, and I can take this voxel size and I'm going to change the mode to block based. So here we're going to give the size of the noise, a bit like with the attribute noise, but like basically what's the frequency of the shredding that we want here. So like this thing is going to create a noise and it's going to create a bit more detail into our shape. So here in this case, this one is going to be the low frequency one, so I'm going to add it by 15. And so here it's going to be the block size of 0.015. Strength 25, that could work. Let's see how it works, how it looks. And basically now we're just going to merge those two, and this one is going to be disturbed high. And obviously I'm going to give a smaller one, so I'm going to multiply by 6. So like you can see that we have our noise size is going to be 0.05 for the big and 0.06 for the high frequency one. I'm anticipating this to be a bit too shredded, but I think it's good for the example. Okay, you can see now what's happening. This is a disturbance happening here. So you can see like the kind of the frequency of our big one, how it is creating those low frequency disturbance. Obviously is way too much, right? You can see now how it's exploding. And it's also maybe a bit too low frequency, so we can maybe just multiply it by 10, and the other we can try to multiply it by 4. Usually it's better to not go lower than twice the size of the voxel size, because otherwise it's going to look a bit grainy. And let's do small tests, so we can do strengths of 1 and 1. Something so that we don't want this to be overwhelming, right? So now let's try again, see how it looks. Okay, we'll come back to something more reasonable. can see it in some space. But yeah, all in all, seems to be working. Now it's very hard to judge the smoke like this without the underlying geometry. So let's just switch to show all objects. And if we can't see the other one, you can just put the flag back on FX work. And that way we now have our beautiful mask. Let's move back to smooth shaded. And yeah, with the light. Always be easier to visualize your volume with light. Okay, you can see that now it's still way too crazy. So I feel like we're injecting too much velocity, and also that our disturbance are too high still. So let's reduce both of them. Actually, we can, for now, let's try to find a good amount of velocity that we want to inject. So here by default, I'm just, putting the velocity in add. Let's, put 0.03. And after we can also try to add the temperature, and then after we'll finish with the disturbance. Okay, let's put this back. Okay, but at least we know now that it's actually activating at the right spot. And it looks still a bit soft, so potentially we would need to make our source a bit sharper and potentially decrease the voxel size. In terms of velocity amount, we have something that looks okay. Maybe now we're spinning a bit too fast, or just not sourcing enough density into it. So let's do the tests. Let's just reduce dissipation by half. And now we can just also increase a bit the particle scale. Okay. And now, yeah, let's have a look. Let's see how. So, this is Pyro, so obviously you need to iterate quite a lot until you have like values that you like. But at least basically the whole system is there. Like, we This is how we source our volume, trailing the okay, looks maybe a bit dense, but we have some interesting things happening. Obviously here we're still a bit low res as well. Always start with low res and then you can, like, you know, work your way to high res. Here, like, we can see that he's expanding a bit too much. Maybe I think we're sourcing a bit big in terms of the particle scale. The velocity amount looks alright. Dissipation is still better. Let's go back to something a bit more smaller here in the particle scales. So it's back to 2. And now let's try to add a bit of buoyancy. So let's put something very small for the buoyancy scale, 0.01, 0.001. And let's try again. So now we want to make this smoke a bit hot. So we want, like, you know, to have this push forward based on temperature. Yeah, the size of it is better now. And obviously for now we're just starting in the mid frame because we don't want to recalculate all the first frames, just to check how, like, the main behavior on when we're sourcing the Pyro. But obviously you can imagine that there will be already some stuff here. Okay, so now the flipbook finished. So we have, so obviously, yeah, here way too much buoyancy still. So I think we can turn this down quite a lot. Even though we're playing with already very small values, let's just try to reduce that even more. And potentially as well, we can change the way we're adding temperature as well. So we can actually switch to pool, and we can just basically reduce the amount of temperature that we're sourcing it. Basically, pool will change a bit the way we're sourcing the volume, so we'll not just keep adding. We have, like, the acceleration strength and dissolution strength. So basically what we were trying to do, we're going to try to go towards a value that we fixed, and then the value can go down. So basically this is the acceleration threshold and the dissolution one. But basically, so we have this source, this destination value that we have, and basically we'll just avoid adding on top until it becomes way too much, you know. So it can create something a bit more dynamic in this case. So cool. Anyway, it's going to be something pretty subtle. So yeah, we don't want something very, very strong. And here on this one, we can just add very subtle disturbance back. And yeah, let's do another flipbook. But yeah, between the velocity that we're already injecting it, like, we just want a very subtle buoyancy happening here. One thing that we can do as well, if we want, like, you know, something a bit more responsive, we could cache the source as well. you know, that way, maybe I'll do it just after that. So basically pre-caching the source, so that way you're not just recomputing all the transform PCs and activation threshold and all this. We're actually just directly putting the volume in. In the meantime, maybe we can have a look at the documentation. So if I do Pyro or volume source, actually, you can press F1 and you will actually see all the documentation of Houdini. And here, if I do in volume source, and I just type, for example, control pool. So like, you know, this is all the way we can add fields into the domain. And so we have this target field towards the spring entry and source volume. So here, yeah, it's a bit it's not very precise what they want to see, but what want to say here, but basically we're aiming for an amount of temperature, and then acceleration strength is like how fast is going to go to this amount and how fast is going to decelerate from this amount. Okay, now at least we can see that we don't have any crazy high disturbance. So yeah, all in all is going already in the better direction. So here, yeah, that's why basically I think now maybe our temperature is not high enough. Because like, yeah, the feeling I want to try to avoid is having the dry eye feeling where, like, you know, the smoke would push down. I think it's always a bit interesting when we have something going up here, just to make it feel hot. Then obviously here after we'll increase the resolution just to make it look a bit more detailed and interesting. Okay. So let's actually just put back, we can put it back to 0.5, we're increasing it. And here, let's try to do something a bit smaller. So actually here I'm dividing by 2 the voxel size, so I'm going to put 8 times more voxel. Something as well that I forgot to mention, that we're going to go towards like high res in the viewport. By default, basically Houdini is going to try to reduce, like it's just going to give you, it's going to clamp basically the amount of voxel that is going to display here. So if you press D and if you go to texture, make sure you have something a bit high here, 1024 or at least 512 depending on your graphic card, but you want to avoid a bit from like the 256 because otherwise you're going to increase the resolution, but you're not going to see any difference here. But like it will be longer in to calculate and all this, but like you won't see it in the viewport. You know, it will just clamp this value for you, and like you'll be only able to see it in render. But 1024 is good in most cases, because yeah, more than this usually can be a bit heavy to compute. Usually it's pretty important to just choose a frame in the middle like this to do your settings. Because otherwise, yeah, if you just do on the first frame, you will like, wait way longer time to just get do your adjustments. So yeah, here we can already see this looking way more interesting as well as soon as we reduce the voxel size. In the actual solver itself, here we're actually waiting more time in general on the procedural stuff than the actual sim itself. But yeah, all in all, looking bad already. Maybe just not enough buoyancy now. Can try to increase a bit those values. But yeah, but we have some interesting stuff here already. And we can increase a bit the high frequency disturbance as well, just to get a bit more detail. Like this kind of like noisy patterns a bit in the smoke. So cool. Interesting. We know what we want to do now. Okay, so let's actually increase by 5 the buoyancy scale. We can increase a bit the disturbance. Sometimes I just put like a multiplier here, so that way I just remember by how much I multiplied since the last iteration. And yeah, we can do that. So basically here, like we can just continue playing a bit. What we can do as well, we can cache our particles or source particles. We can actually see that, for each frame, it's actually taking a bit of time to compute. This one is okay. Yeah, it's mainly this and the trail, because like now with the trail, we're going to look at like, three frame each time. So yeah, what we can do, let's just try to get rid of some of the unnecessary attributes. And we're going to cache our source. So here in this case, I can just keep I can keep the density after. Those are not very heavy operations, so I think I'll just keep after the resample. So I'll keep P scale, I'll keep V, obviously, I'll keep ID, and that's about it. And now I'm just going to create like a new file cache here. So I'm going to copy one of those. So it's going to be time dependent, but not simulation. and the lower S again. Call it volume source, and then we can just cache this to disk. And then after this, we'll be able to adjust the Pyro a bit easier. So yeah, let's wait for this to finish. Oh, actually, before we press this, here I just forgot. Let's do delete non-selected. Yeah, and then we just cache this. Okay, so now I catch the source and just relaunch the sim as well. That's what we have. Overall, I think it's looking pretty nice. I like the disturbance that we have. It's just like it's globally too much. So yeah, what we can do here, we can try to reduce the particle scale in our volume rasterize. Switch it back to 1. And we can try again to just reduce slightly the let's put 0.35. What's this? For some reason it's crashing. Okay, let's close nuke. Okay, how many voxel? 300k voxels. Okay. Yeah, sounds reasonable. If I just look at the rasterize. Okay. Yeah, it looks way thinner. And so I might just reduce. No, actually, okay. Cool. Let's go back to our test frame, and just maybe we can switch it back. This we can just reduce it a tiny bit to 5. And here I didn't see any real difference in the buoyancy, so let's put like this source scale at 1, and let's multiply the buoyancy scale by 10. Cool, and see how it looks. All right, so this is what I have at the moment. Still baking, so here I'm like at 13 minutes for 90 frame. So it's okay, it's not too bad. It's not quick, but you know. For now we're using CPU, so you can also enable OpenCL. I'm just going to save this one. I save the blue book on disk. Okay. Press escape. Switch to auto update. And now I'm just going to have a look as well at the amount of voxels that we have. So here we have 240 million. So yeah, like I mean, all in all, I mean, we can potentially push the resolution quite a bit as well. But there's a few stuff we can do. We're going basically now to prepare the caching to disk. Here, so at the end I switched the pole to 1, and I use this value for the buoyancy scale that kind of give me what I wanted. This is the value for disturbance. So basically, yeah, that's it. Here, by default, we can see here we're in Houdini volumes. So it's great for a lot of things, but basically it's pretty long and heavy. It's pretty heavy file format, so usually the best is to convert to PDB. And there's actually several stuff that we can do. So the first thing we can do is Pyro post process. And here you can see it's actually going to convert to PDB, convert to 16 bits. Float. All right. And we can do as well is resample the velocity. So basically here what you can see, we go from 0.035 to 0.07 because we have like a voxel size scale of 2. And this basically is like we're going to downsample the velocity just to make it a bit faster to cache on disk. So yeah, that's like, switching to 16-bit floats. We really need the 32 bits, so this is going to reduce quality. All of the small things really help to keep a good size on disk. And now I'm just going to steal one of those. Switch back to $OS, and I'm going to do smoke simulation, real good. And in this case, so we can potentially keep it like this for now. I mean the voxel size, just for caching, and then we can go until the rendering with this, and then after we can probably decrease a bit the voxel size and cache a higher res on disk before just running during the night or something. Here, if you have a good graphic card, you can try as well to use OpenCL, and you can accelerate the computation. So yeah, that's fair. Let's cache this to disk and then come back on this. Okay, amazing. So this is what we have now. Simulation finished. And yes, this is our volume. And now we can actually just put a null and put it out. All right, amazing. We can start potentially to do a few tests of rendering. We didn't render the mask yet, so we can go to FX output. In mask render here, I'm just going to drag and drop Disintegration here, and in the smoke, I'm going to drag and drop as well this one. All right, cool. So it's already linked. If I go to the ROPNet, we can have a look at this smoke and this beauty. So basically the beauty is going to be everything together. So we're going to take the human, we're going to take the under mask, and we're going to take the robe and the mask render. So the under mask, we actually didn't work on it. So we're going to do it in a second. But like in the meantime, we can see how it looks with our smoke. To render the smoke, I did a small emissive shader. We want something a bit flamey. So basically we're just going to give the density field into the emission channel. So let's just wait a bit until it generates the scene. So if I look at the smoke, I can have a look at the shader here, smoke shader, and it's actually just this, the standard volume. But basically, we're just putting the density here, and I'm putting a color in the emission based on the density, just to have like this kind of flamey look. Okay, doesn't look too bad. We can increase potentially just a bit the emission. Might need to regenerate the scene. But I mean, like, you know, we have also quite a lot of flexibility in comp on how bright it's going to be. So we don't need to spend a lot of time here, especially in this case where it's just an emissive shader. We have this alpha and the color, so I think we can basically turn off all the lights that are here inside. See, so now we have something a bit more contrasty, so yeah, I think it's gonna look good. Great, and now for the beauty. So I mentioned something about the under mask. And here the under mask is basically, if I go back here into FX work. So we have this, and obviously, like, you know, we want to have a surface behind it, right? So to do that, we're actually just going to create a new geometry called under mask. Dive inside, and we're going to get the very top of our disintegration. There was this inside part here. And so it's actually just going to, we're actually just going to do a special treatment for this under mask thing. And yeah, we're going to make it emissive. So here in this case, basically I'm just going to give it a noise. So first I'm going to reverse the normal. So it can face our way. And yeah, basically I'm just going to create an attribute up. Do turbulent noise based on the position. And put this in a ramp. And yeah, I'm just going to clamp the values just in case. But the ramp will do it anyway. Cool. Then right click on turbo noise. We put this input here. So I'm going to call it noise color. And sparse convulsion. Let's increase the frequency quite a lot. And here in this case, I'm just going to delete the material so we can see it a bit clearer. All right, it's not looking bad. What we can do as well, we're just going to subdivide it a bit just to give it a bit more data. And for the frequency, basically, I'm going to give like, yeah, 150 or something. Cool. And then with the ramp, I'm just going to give it a dark brown here until we can keep the white, but we can put maybe also an orange in the middle, bright orange. Okay. So yeah, basically this is what we're going to have now. Okay, so remember now we also need to transform it. So we can actually steal this transform piece here. Just so it follows the animation as well. All right, and now we can see that we have this under mask thing. And And yeah, this is pretty good. So now let's do out. So yeah, this one out, perfect. And so now we're going to go back to FX output. By the way, I put those quick marks so you can go between 1, 2, 3, and 4. So like the renders simulation is 1, the output, so the render nodes 2, and the shaders 3. So yeah, here I'm just going to do this, just link this on to under mask. And actually there's also this light mesh under mask. Here it's already kind of set up for us, and it's just going to, we're going to have a mesh light, and it's going to take the color for us. So the color is going to cast shadows. It's going to look, the color is going to be multiplied by the exposure, and it's going to give the color of our light. Cool. So now if I switch back to beauty, it should basically render this light here. So the interactive light, the under mask, and the other element. So now we're just evaluating Python. Here, so why did I put this in 2 different ones? Is because sometimes if it's getting a bit too heavy, we can give a proxy in this one and still render the under mask high res. Cool, so we're just going to wait a bit. But yes, now we have the mask, what's under the smoke. Next one, now we're going to work on some Advected Particles. All right, so we have. Okay, I might just increase a bit the sun here. Getting a bit slow. Here's my graphic card. So when you, I'm just going to cancel it. This beauty here, we can also switch the device. So by default, it put the GPU, but you can switch it to CPU, basically depending on how, how good is your GPU. Here, there's already some AOV set up for us. We have 2 different light AOVs. This is going to be the inside light is the one with the mesh light that we just created. So this, we're going to have the surface that's going to shoot rays, and the under masking is going to cast shadow and protect a bit. So it's more like a light coming from the inside. So we can see as well that there's some shader assignment problems for those 2. So let's just go back this. So the robe doesn't seem to. Okay, all right, that was the wrong shader. So it's supposed to be robe 2. And yeah, now we can just retry again. And yeah, here I just increase a bit the sun to get something a bit less flat. But we'll have control as well in comp with those AOVs anyway, so we can always readjust a bit the the exposure of the different lights. Can take a bit of time to generate the scene. This is the albedo pass, so just the actual textures inside. So what you actually can see here on their mask, there's like the color is put that's under like a separate AOV, so that way we can also touch it. All right, way better. So we can also, like, control our color in comp. And remember, like, we did the groups. So here I feel like the groups are not working anymore. We're supposed to see the RGB. So let's have a look. So our mask render. Here, do we have the groups? Oh, okay. So basically it's just here spelling thing. We just need to put groups with S. And then we're if I just re-render it, we should be able to see the edges, the back faces, and the front faces into different color. And then you can use this to grade them. Like, for example, when they go far, you can try to put a bit of glow on the edges. That can be, you can art direct this. Cool. So don't forget as well when you're about to render to put this where you want it to be. By default, like, you have this version number thing. But it's going to save in your dollar job. So, like, if you want to use like another, you can put dollar cash. And you're going to take this version as well, so you don't override your renders. And yeah, you can adjust the samples. Here 12 was fine with the GPU. It was really fast. So yeah, that's it for the rendering part. So you can feel free to just render those two layers. So yeah, they are like in OBJ RobNet, not in out. Cool. Now let's just have a look at some advected particles. So now all right, so this is what we have. So we can like isolate the edges. And obviously here we don't see them just now. The green one. You can actually check here how it is going to look if you do put a color node on the side and you do ramp for attributes. And here we're going to put groups. Gonna check that it's kind of working. Did I forget? an exploded view. So we have red, we have blue. Oh yeah, I think it's because they are basically on the points where they should be on the primitive. And after this, we can change the primitive as well. Okay, so yeah, now we have those R, G, and B. Great. Cool. Now let's just work a bit on the Advected Particles. So I'm going to create a new node, and I'm going to put Advected Particles here. So basically the beginning is going to be pretty similar to our smoke. So, we're going to take this part here. It's basically just like big scatter as well. Then we transform again. And after this, we're going to... So when we set advected, first what we can try to define a bit what advection is. Advection is transforming particles in 3D space based on a grid, and so like usually volume and like a velocity field. So basically we're going to have a field with directions, so vectors pushing into a direction, and basically that's how you get some particles to follow a smoke or something like this. So here in our example, we can directly take we can take the smoke here, the volume on the side, and call it get volume, and then here inval field. Now I'm just going to create a pop network. Gonna dive in, switch the emission type to all points, and now we're going to type advect by volumes. And here it's going to be in the val fields, and we're going to update this to data velocity and here to trace. All right, cool. So now let's remove the guide, and the impulse activation is always going to be 1. Great. Let's take a small noise. So we can just take it's gonna be a bit easier to actually visualize the motion of it with noises that don't look all the same color. Cool. Obviously here, let's base this on rest. So we're going to create a bind, free float vectors, put rest here, plug that in the position. Here nothing happened. It's probably because we didn't actually declare the rest position. So we're going to put this before the transform pieces, so we have something that stocks. And great. So now let's do a small flipbook and see if everything is working as expected. So in general, it's fairly fast. And then you can see those points that are actually traveling along this velocity field. And we can see that they actually look, they're actually matching, you know, the look of our smoke. Okay, and here in our case, we're doing this to kind of add some detail in the smoke and add some very thin highlights. So in order to do that, we're going to need the quality of particles, and we're also going to need to break them up with a lot of noise as well, just to emit in very, very specific areas and have something very thin and a bit wispy. Because here, like, it already looks a bit confusing. There's already a lot of stuff happening. So it's a bit hard to identify the different highlights that we want. But we can definitely see that it's working. We can see the motion of it. So yeah, that's great. What we can do as well, while we're here, we have a P scale from our scatter, so we can actually switch to disk. And when we switch to disk, it's actually going to show us more or less the size that is going to be rendered. So just be careful, like if you don't have a P scale, it's going to put a P scale of 1, and so that can look very big into your scene, depending on the size of your scene. But yeah, here now we have something that looks a bit more. And if we want to approve, we can actually, if we multiply the P scale after times 0.1, see everything's going to be very, very thin. Okay. Cool. So yeah, now let's just try to break up this a bit more. So here we can just put let's move our arrests, and we can put our propagation obviously here. Let's actually see how much we have. 3 million points, so we can go a bit higher than this, to be honest. So let's go 30 million. It might hit the limit here at 10. Yep. All right, so let's just switch this. You can just link the two, or you can just turn it off. This is more useful if you play with density, just to avoid having like crazy amount of points, depending on the scale of your scene. So 30 million. It's gonna be fairly long to compute. Okay. Let's switch back to points now. And so here, after this, we're going to put the blasts. CD.R higher than 0.1. And we're going to switch this to points. So basically here, we're going to delete quite a lot of the points. So you can see that now we're already just at 8. Okay. And now we can do another pass of something even more high frequency. So let's put like 1.5K. Okay, so now this is what we have. We have 2 million points. And now let's go there. Let's do a small flipbook and see if we manage to see something a bit more defined in wispy. Switch to disk. Okay, yeah, looks definitely interesting now. So yeah, now here we're creating detail out of the smoke now. We're really localizing, and then we can actually read the different tangents. And after this, we're going to play with the age of the particles as well, so to make them fade off over time as well. But yeah, like particle advections are a good way to add details into volume, and especially for magical effects, that's something that we use quite a lot. Okay, nice. Okay, cool. So now that we have kind of like everything kind of working for now, we're going to start and do a first cache. So I'm gonna grab one of the file cache we already did. So this one, for example, and going to put back $s dollar. Call this affected particles. Sim. Cool. Few stuff where we're going to clean, so we can potentially keep more or less the same thing as this one. Put an attribute delete just to clean everything that we don't need. We keep pressed. Let's keep pressed in this one. And it was not okay. We're going to store as well the source frame. So it's going to be the frame, the birth frame of the particles. So I'm just going to put this here, and I'm going to put this in the list of attributes we want to keep. Cluster name ID, rest, active frame, more or less the equivalent. Do we need other attributes than this? Yeah, let's keep the UVs as well. I mean, here in this case, we will not necessarily need them, but okay, cool. And we can put like just a group delete, something I like to do, just to remove all the streams and all this that we usually don't need. Okay, sounds good. So let's cache it to disk, and then we're going to do all the possum stuff. So let's press this button, save to disk. Okay, now I finished after like roughly 6 minutes. So yeah, now we're ready to go back. So let's switch to auto update. And here, yeah. So here, this is what you might get if like you just don't go to like a small p scale. You might see actually something very small. Here something that we could have kept with p scale, but we can also just restore it directly, so it's not a big deal. So yeah, let's just here call this one base p scale, and that way we save a bit of memory. So put base p scale, and here we were like at very small 0.005. Still too big. Better. Okay, let's keep around this size for now. Great. This is what we have. What we can do, we can try to tidy up a bit this in a second. So yeah, let's first let's steal one of those. Let's call this one P scale. And then we can just put this one sim. Here, val field. Here, scatter. Transform. And activate. Don't have to specify all the steps, but just so we know more or less what does what. Okay, cool. So like the first thing that we want to do, we're going to set up the after the P scale, we can set up the duration. So let's do another wrangle. And you can notice that I didn't save age or life. The reason for that is because I am just going to recreate this here. So we have the source frame, so we can actually ramp the current frame that we're on based on this source frame and the custom duration. So if I were to say duration in number of frame, like this, so I would put like a channel integer. And here I can just say, like, for example, let's say I want my particles to fade in 30 frames. So like, or like, let's just keep it 1 second for now, 24 frames. Let's call this duration. Cool. So now like we're going to create like the equivalent of NH. So here in this case, we can call this like amount. And this will be fitting the frame that we're currently on. And based on the source frame and the same source frame, actually it's an integer, but plus duration. Because at the end of this duration, the thing will be done. And if I fit this between 0 and 1, and I can just visualize this by plugging this in the color. Cool. So let's see, you can already see now that those black stuff yeah, you can see these basically that like those are like emitted more than 1 second ago, so more than 24 frame ago. If I increase it to 100, you can see that now we have a way more progressive ramp. Cool. In this case, I don't think we want something very, very long. So, but yeah, I think we can still put 100 frame just to have something that fade off quite nicely. And here the good thing is we can also we're going to multiply P scale by this amount. So basically you will see that the particle will shrink over time and will help fade out those particle out the way. Now we can do like another condition just to optimize a bit. If amount lower than 0.01, we can just remove points. That way we should still, like here in this case, it's the same thing, but if I were to reduce it, you can see that I go from 3 million points to 2 million points. So it's still something. here, let's just check if so here, like we put the life expectancy at 100, so we're not killing the frames directly in the sim. We're going to do this here pause sim just to have more control. For very, very heavy count of particles, it can be interesting sometimes to reduce the life expectancy if we know that we're not going to go above like 2 seconds and we have like a big frame range. That can be interesting to save a bit of space to disk. But it's always interesting as well to keep it just a tiny bit longer, just in case you need it, and you can just remap it after. Okay, so it's the p-scale duration, and that's more or less everything we need in this case. We're going to remove even more. So here I can actually just do delete by noise. And here the game is going to try to create even more apparent tendrils. So let's do that in a second. Okay, so this is what we're going to do now. So let's switch back to auto update. So we copied this noise based on rest. And let's actually switch back to points for a second in the viewports, because otherwise it's going to explode a bit. Oh god, the graphic card. That's not happy. The geometry points. Okay, a bit safer now. Cool. So we're going to let's try to increase a bit the frequency until we find a pattern that we like. Okay. So here we're going to giving it a color. And here we can actually just blast the points. That we don't want, just to create some more defined highlights. See, so we're removing quite a lot. Okay. So we got duration, and here the last one, we can just call this color. And in my case, I'm going to ramp the color from the color. And I'm going to give it a hot color. So in this case, I don't want pure white, but something pretty light. Something that would give it a bit of a red as well. Okay. So let's do that. Let's just give it another. Okay, wow. And then we have like something. Let's do this before the duration. Oh, and actually here, let's just switch. Let's multiply the color over time. Okay, switch back to disks. Okay, we have something nice with some range in it. Let's go switch to more navigator noise. And we can have a bit more roughness. Okay, cool. So this is going to be rendered like this. Out. So this is going to be like kind of like our template for our next particle layers. So we can basically just duplicate this effect, do another pass at it. Here, so we only have 1 million points. So we could potentially be a bit more aggressive with our initial scatter, just to get something a bit more defined in the tendrils. So like, you know, here you could also just multiply this by 10 or something, and then run the sim by night and just compare the different results. But for now, just as a proof of concept, I think we can just set it's working. So now I'm going to switch back to our FX output here. So there's like already like a particle thing that was already prepared. So let's just put it here, and the render. So like if we have a look at the shader is actually something very simple. So we're just going to we put the color into the base color here, and then those are just attributes that we can store to have a bit more control in comp. So that can be useful. So let's set those up. So noise and life. Basically, yeah. What I like to do sometimes is just remember like giving those different noise options in 2 different channels. So basically, the idea would be to have 3 different noises. One stored in the red, one stored in the green, and one stored in the blue, and then with those information that could, you know, we could get some highlights, some places, like just to give us a bit more control in the comp, or just tone some parts down. And this is going to be some same. It's going to be a bit like, you know, what the amount thing that we did here. So it would be just this kind of ramp. But like, you know, we can give different things. So we can give different life. So just if we want really to isolate the first when they're born, or if we want like a very, so like basically we're going to group those options. So we can create here, let's just put something called AOV, and basically here the principle is we have one noise, so let's skip this one. We have a second noise and a third noise. And here, so the thing is already set up, but basically this is expecting the attribute called noises. And so we're taking this vector and we're putting this one in an IOV right RGB with the same name, and then this is going to be recognized by the output. So here you can see that we'll have noises here. So it will write basically whatever attribute we're giving it into disk. So here to do that, we're going to create a vector. So v noises with s. And here, like, we're just going to store those values into the different components. So first, let's actually keep. We don't want to mess with our color, so we're not going to touch it. And we're going to, so the first inputs stay the first inputs, and then we're just going to connect all those into the second, third, and fourth input. And so here we're going to do vnoise.x equals 0.1 cd btnum. And now we just need to actually do the same for the other. So y is going to be 2, and z is going to be 3. So now we can basically just give different type of noise. So we can create like a sparse convulsion, We can do Perlin noise. We can try to modify the we can try to modify the frequency. And so here I'm going to say store noises. And so if I want just to visualize this, I can just put on the side and type this noise. And random for attributes. So you can see here that we have those RGB stuff. And so those value will be able to extract them. The reason why we're directly storing this into the different RG and B channels that like those channels have a good anti-aliasing properties, so it's easier to just extract them like this. We could potentially store something in an alpha as well if we wanted. So put the victim 4, but in this case, usually 3 is enough. So yeah, this is like our noise AOV. And the live AOV, so basically we can just copy here this duration. And here in this case, we're just keeping the color part that we're interested in. And so here, let's do something very for the first frame. Then we can do potentially 35. And here we can do 100. And so basically like here, we'll just give different options of fade. And here is the same thing. We're just going to store those values. So here, we're just going to switch basically from noise to live. And then we have a very easy way to get those AOVs. And so here, if I switch back to live, you can see that we have those different values. Cool, so let's do noise AOV and live AOV. I'll go over the comp aspect and we can go and see a bit what those do. So if I were now to try to render those particles, this was I can actually check the size. So here in this case, you know, like we're going to map directly the other object as well to be able to put them on top. If you want to do like a quick test, you could put like potentially just remove them from the up. If you just want to test, you can just render it without anything. But here, yeah, we want the matting, and also we want to get those casting shadows onto the particles. Cool, so it can take a bit of time. Okay, so now you came back. Obviously here something went wrong because we're not expected to see those particles. So let's just try to see what went wrong here. So if I just remove everything else, just try to render those. But here, like you can see that it's already kind of doing what we were expecting. You know, like the those kind of very fiery things. Okay, which is good. Don't know why this thing in the force mat make him freak out. But basically, yeah, it's basically the mask render as matte. We just want to like basically matting is removing everything that is behind the mask for us, just so we can actually put this on top of it as a over B. So yeah, let's just try it with the mask for now. I think should be good. Cool. So we have this ready to go. So basically now the next step will be to use this kind of same workflow for those advected particles. So now we're going to play more with adding some small debris directly from pop. We're not going to go from rigid bodies this time. And yeah, we're going to instance some ashes kind of geometry, pieces of geometry, just to create a bit more detail in the look. It's going to be more or less the same type of workflow as this one. But yeah, just to add like another element. Basically, we have the smoke, we have here those advected particles. It's going to be more fiery look and our highlights. And basically now the debris after is going to recreate some darker spots in the rest. So don't know why in the mask render. I might just try to close and reopen just to see if Pyro is freaking out about something. Oh, I was actually not on the correct thing. So yeah, a bit weird this though. Are we the human is okay. Seems to be the robe. Let's try to just unpack it just to see if that might be the issue. Just bring this back in there. Maybe it's an unpacking thing. It'd be cool to keep the robe, that way we can have some of the shadow casting from the robe. But yeah, it's probably like an unpack thing. Cool, let's see if that works out. And yeah, another thing that we can also do, again, is a separate pass. Currently, we're only having like the pieces as very thin surfaces, so we can potentially try to add a bit of. Okay, yeah, that was the attack of matter inside, just so it doesn't look so thin. Of course, with the secondary, it's going to help anyway. It's going to fill up the it's going to fill up the screen space already. All right, it's looking pretty nice. But yeah, we can add like some other thing, and I feel like I'll just go through the comp, explain a bit the AOVs, a few stuff, and we can do some tag passes after this. Just like exporting some AOVs and just like look at the comp, see what we can improve, what we need to do the effect that we want to do. But at least now we have our 3 main layers that are ready, and then we're just going to go through the debris in a second. All right, let's switch back now to those debris. So yeah, like those debris are going to be, so like, you know, like those affecting particles are the flame. Like we have our nice volume in the middle, and now we're going to try to add even more detail with small instances. It's better to use instances than just spheres. It's going to create a bit of complexity, and we're going to be able to add rotations, and it's going to look basically overall way more organic. Here in this case, there is no real need to do rigid bodies, but like for more complex cases where you would need proper collisions, all this, you can also just do rigid bodies. And you can have a look at maybe at the other tutorial I did on this. It was with the it was for Robo as well, with the wave of debris and like small debris instances and all this. But yeah. Anyway, let's get started. All right, cool. So back in Houdini, what we can do here in this case now, we can just duplicate this advected particle thing and just call it debris. And here in this case, we need way less particles. So, you know, we can potentially reduce the count 10 times less. And we can also remove some of those noise. We can do it maybe after. Pause sim. So that's about it. Let's keep the P scale this time. Don't want to kill it. Cool. And here in the dead velocity, let's use a Vx expression. And on the velocity scale, see here V scale, we're just going to vary this. So we're going to do a rand ID. And we're going to fit this. So rand is going to give us a value between 0 and 1, and we're going to ramp it between 0.2 and 0.6. So not fully advected, but just a bit less because it's supposed to be the breeze and not fully static neither. So this range seems quite nice. We still have this source frame attribute now. Let's put back $S, and this, we're just going to call it the sim tutorial. And in this case as well, I'm just going to offset a bit, just so we don't source the breeze a bit too early. So I'm just going to offset this to maybe like 0.5 or even 2.8. Cool. So this is actually useless. This noise here. I think this was just for us to viz. So yeah, let's see. Let's basically see how it's evolving. It's probably still a bit too much, but we're going to do some. We're going to rework a bit on the size anyway. So we're on disk again. Yep, okay. So I just want to check the. Let's put back our real main integration. Okay. So here, yeah, we're sourcing directly from those cracks. It's okay. It's nice to have a little bit more of those debris out. Cool. Let's save this to disk, and then we can do a small flipbook when it's over. Okay, so this is what we have now. Okay, so we have like roughly here 2 million points. It looks maybe a bit too much. So what we can just do for now, we can just remove an amount. So I'm going to do rand equals rand idea. And I'm just going to do if rand bigger than a threshold. Just remove points. And that way I can just be more easily control the amount that I want. Small seed. It's actually the other side. Okay. Okay, that way this is a way more a bit better for my brain. Just here I know that I keep 10%, 0.1. So I'm just going to put here delete by ID. And so all the rest is kind of good for now. Cool. So now we're going to work on the instance itself. So like the pieces that we're going to instance on this. So to do that, you have like several options. You can do like, you could do a sphere that you scale down on the one side, and then you can potentially like do a mountain. You know, something like this. In our case, we'll try to find something a bit more broken up. So we can keep this actually for now. Let's keep it to switch to polygon and put something pretty high. 13 like this, yeah. Let's reduce maybe a bit the mountain. And the element size. Okay. Let's do like just a standard sphere. Okay. And so basically we're going to just create kind of like just debris. So to do that, very simple. To scatter some points. So here I'm just going to create like 10. And I'm going to randomize the normal. Inside sphere. And copy 2 points. Okay. We can reduce this quite a lot. So we know it's a 1 unit sphere, so we can just put it 2 by 2. And we can potentially add some subdivision as well. All right. And now we can do mountain. Okay. And now we'll do a Boolean fracture. So we'll do override here. Yeah, let's see if that's kind of working now. Yeah, just doing what it's expected. So now let's just try to put a bit more. Okay. So here, like, we have some interesting shapes. And we can actually just, explode view here. We're going to select a few of them. So I'm just going to put a blast. Here in this case, it's going to be pretty far away anyway, so we can just select 4 that we want. So I'm just going to press 9 in the viewport and just switch to the wheel here, and try to find someone that could look a bit nice. So in this case, we can choose some crazy pieces. We don't mind it too much. So let's select 4 of them. Yeah. Delete not selected. So we have those 4 here. And here we're going to let's do a for each name primitive. We're going to normalize them. So we can do transform. We're going to do $$cx, $$cy, $$cz to all snap them into the origin. You can actually save this as well. If you do save presets, that will you already can save some presets here. So here we can call this one sap center world. Sure, you will use it several times. And now here we're going to do max. We're going to divide this by the maximum of the bounding box. So we're going to normalize them in size basically. So we're going to do max b box, the x size. We're going to compare the bounding box on the x-axis, the z-axis, and basically we're going to do a max between this and the b box in y. Okay, and basically just the other here will change. So we need to do transform first and then scale. Of course, now they're like all normalized in size. So we're good. And basically what I want to do now, I want to give them like an object ID. So here, create meta import node. And I'm just going to create a wrangle. I'm going on the wrangle to create a spread input. Put this one here, and I'm going to just create a object ID equals detail -1 iteration 0. Is it working? Okay. So now we can see that basically we're giving this value between 0 and 3. We have like 4. And it's going to be easy to randomize our instances on like, basically we need to, so this is like a value between 0 and 4, and we really need to say, oh, okay, you take instance 1, you take 0, instance 0, instance 4. So those will be done here. Cool. Let's go here. We can try to do a copy to point already. Before we do anything, let's switch it to pack instances. And we can copy this. And I'm just going to Shift R just to reverse the thing. So the geometry is on the left. And here, basically, we're going to do this piece attribute. So in this case, we're going to call it object ID. And the thing is, here, nothing will appear. So they put all of them. And the reason for that is we need to define the object ID. So I'm going to put an attribute randomize. First, an attribute create called object ID, just to specify that it's an integer. And here we're going to do the same one, and it's going to be just one dimension, and it's going to go from 0 to our maximums. Here, like it's going to, you can see it's going to go between 0 and 1. So if I were here to do a color and randomize based on object ID, we could see that basically we're just going to have like two different instances. So I could potentially just, put here between 0 and 3. And here in this case, it's probably easy. I think that we do sometimes, like if we just want to add another instance here without having to change all the number and all this, what we can do is actually pretty simple. So we're going to put here, we're going to do in instances. And basically we're going to, here on our attribute randomize, create this pair input, and we're going to link this. After this, we're going to do here an attribute promote. And we're going to remove delete original. We're going to do object ID to detail, change new name. We're going to go to maximum, max ID. And here, if you switch to detail, you can see that this is the maximum number. So basically here we could do detail -1 max ID 0. And here is going to give us 3. So the good thing here, for example, like I say, oh, okay, I want to add like this one now. Now I have 5. That's okay. It's linked. So it's going to create like an extra one for us. Cool. So this is nice. Overall, the P scale, they're too small. So let's just make them bigger. What we can see is that they have all the same rotation. So let's just do an attribute randomize, and we're going to call this one orient. Is going to be 4 dimension because it's a quaternion. And here we're going to put pi here, so 3.14. And I'm going to copy and paste it in all the different components. In here, the negative of it. Okay, so now we can see when to weirdly all attached to. Now they have like all different rotation. Cool. So we can call this small thing orient. Okay. And here we're just going to do in point cloud. So we could try to render the points. Arnold is not a big fan of this, so basically we're going to render the point cloud in an instancer, and we're going to create those instances ourselves. And here we can just create called object ID, just keep it nice and steady and organize. Cool. Okay. So now that you can see that we have a pretty uniform size variation at the moment. So we can do an attribute randomize. And we're going to put P scale. So 1 dimension. But here, we don't want to lose this base P scale. So we're just going to set it to multiply. And here we're going to switch as well into custom ramp. We're going to, you can see that now we already have a better size distribution here. We have some very small ones. What I like to do from 0.3 to 1 and basically give a lot of small ones. I feel like this looks usually nicer. So we go from here with all the same size to something like this. Looks a bit detail. Cool. What else have I forgotten? So that's kind of the main idea. Now, obviously, we could make those instances rotate a bit like the same thing that we did on the main iteration. Based on their source frame or active frame. But here in this case, I will not bother. They're going to be pretty small anyway. Yeah, here the only thing here you can see they will spawn pretty big and then decrease in size. Usually it's not the best idea to make them big on their first frame because otherwise you might get some popping here and there. So I'm going to remap this. So what I can do here in the middle, I can do amount equal 0 ramp. We're going to give this very easy name like ramp, and we're just going to ramp amounts. So here it's going to be the same thing, right? But basically here the idea is let's make them small at the beginning, then big, then small again. So they will grow and then okay. Cool. And so this is what we have now. think the amount is good, but we know we can also try to see if we want to be more, a bit less. Maybe 0.2. We can try to render it now. So to render it now, we're going to create. Let's just copy this one. I'm going to call it debris. And we can just remove this for now. All the matte. And now I'm just going to go to FX output. I'm just going to create something called an instance node. I'm going to type inside, and I'm going to create the point, get the point cloud here. And we're going to call this debris instances. I'm going to go to fast point instancing, used to the velocity attributes for the motion blur. For the shader, I can use the same as the particles. And now here, we're going to call this debris 0. And so here now, we're just basically going to object merge those. And here, like, we have all of them. So basically, I'm just going to put blasts. And I'm just going to delete by object ID. Delete non-selected. Cool. So let's create our 5 now. So here I just need to do 1, 2, 3, 4. Like, once again, like, copy to point might work. Like, you just need to do some tests. But here I just felt like it was a bit faster with the instances still. So I'm just going to show you like this method, but like maybe copy to point still works now. Cool. And then here the idea is we're going to specify the instance. So we're going to give it a path. So we're going to do base path equals CHS path. And we're going to open this. This is going to be the path basically. And then we're going to do this string attribute called instance. It's be the base path plus TOA to convert integer to string. And it's going to be object ID. TOA actually with the attribute. Okay, cool. Let's see if that works now. So we're going to try to put this one here on the debris, and let's just see without anything in the meantime, just to see if it's actually working. Okay, generating still. Okay, actually I did a small mistake. I put the material in the instance instead of putting in the material. So now you can see that if I have this small visualization in the viewport, so it's gonna work. Cool. And now if I just try to render it again, the breeze. It should work better now. Come on. Okay, and now it's rendering. Cool. So obviously we could do some stuff in comp. I mean like in shading, but like we're going to turn this down in comp anyway. So like we can, we can adjust as well the, and like now we're going to have shadows as well when we're going to put back the two different ones, the robe and the mask and matte. So I think basically now we have like this proof of concept that's kind of working. Maybe now it looks a bit too busy. What you can do, like, you can just save a single frame and try to assemble everything in Nuke, or just render all the layers together, and see, depending on your case, how's the size, how's everything, how does it look? Is it looking too busy? Is it looking okay? Could you get more detail? But yeah, so we covered this part now. So yeah, I think in the next video, I'm just going to dive in a bit inside the Nuke, and we're going to talk about how we can make this thing better, and tech passes, AOVs, and just a comp thing. Cool, that's it.